What if definitive proof of alien life isn't waiting in some distant galaxy, but is buried in the red dust of our next-door neighbor? For decades, we have asked the ultimate question: are we alone? Now, new discoveries from the surface of Mars are revealing clues that could change everything. The story of Mars is a tale of two planets. There is the world we see today, a cold, irradiated desert that looks hostile to life. But billions of years ago, Mars was a world of possibility. It likely had a thicker atmosphere, a milder climate, and liquid water. We are the detectives, sifting through ancient clues to solve an old case. To follow the trail, we travel back billions of years. Orbiters mapped dried river valleys and ancient lakebeds, proof that water once moved across the surface. Among these targets is Jezero Crater, where the Perseverance rover landed. From orbit, it shows a textbook river delta, layers of sediment where water slowed and spread. On Earth, deltas preserve fragile traces of biology. If life ever existed on Mars, Jezero looked like the place to hunt for its ghost. Detectives need evidence, and our robots have been collecting it. The first major clue was not a fossil, but smaller building blocks, organic molecules. For years, the Curiosity rover drilled into lakebed mudstones and found complex carbon-based compounds. Organic does not equal life, but it shows the right materials were present, like finding bricks and lumber at a construction site. It does not prove a house, but the parts are there. Perseverance expanded the case. A 2024 sample nicknamed Sapphire Canyon held a mix of elements essential for life: organic carbon, sulfur, phosphorus. That suggested Mars had not only water, but the basic chemical ingredients needed for life to emerge. For decades, the clues stayed circumstantial. Water, organics. Tempting, but not proof. Attention then swung to a rock not on Mars at all. In 1984, scientists found a meteorite in Antarctica called Allen Hills 84001, ejected from Mars by an ancient impact. Inside were tiny structures that looked like fossil microbes. Debate followed, but non-biological processes could explain the features. So we went back to the source. In July 2024, Perseverance explored an ancient river channel and spotted a mudstone with pale splotches, nicknamed Cheyava Falls. Using its instruments, the rover scanned those leopard spots. The chemistry was striking. High concentrations of minerals like vivianite and greigite, which on Earth often tie to microbial activity. Even more suggestive, the minerals formed bullseye textures, patterns seen where microbes organize chemistry to harvest energy. Mixed in, the rover detected a strong signature of organic matter. A later analysis argued that while non-biological explanations cannot be ruled out, the textures and chemistry resemble signatures of microbial life. Where does that leave us? We have a watery, habitable Mars. We have materials for life, organics, and key elements. And we have a potential smoking gun, a rock with mineral patterns that mimic signs of ancient microbes. That moves us from finding habitable settings to finding potential biosignatures, patterns hard to explain without biology. Still, science sets a high bar. Unknown Martian chemistry could create similar features. The rover's instruments look from millions of miles away. For a verdict, we need samples on Earth. That leads to Mars sample return. The core drilled from that rock sits sealed in a tube on the surface, waiting for pickup. The proposed campaign aims to deliver those cores to Earth for tests only full laboratories can run. Thin sections under high magnification, precise isotope ratios, contamination controls, repeat measurements across many teams. Only then can we decide whether those leopard spots are fingerprints of ancient microbes or tricks of unusual geology. This is why patience matters. Extraordinary claims require converging lines of evidence. Context must match chemistry. Texture must match isotopes. Independent labs must replicate results. A yes would be monumental, showing that life can arise on wet worlds and reshaping our search across the galaxy. A no would still be a victory, revealing how habitability forms and fades, and teaching us to read the rock record on other planets with greater care. So the case stands open. Mars keeps offering clues, and we keep building better tools. The next chapter depends on returning those samples and letting the data speak. Until then, we stay clear about what we know and what we do not. We keep methods tight, claims modest, and curiosity relentless. The answer to one of humanity's oldest questions might already be sealed inside a small metal tube on the red planet, waiting for us to open it. Comment your thoughts. Share what you think the strongest clue of Martian life is so far. Like this video if it sharpened your curiosity, and subscribe for more clear-eyed explorations of space and science, only here on Next Gen Science. Let us keep exploring together.